Right, welcome back. In the previous video, what we've gone through is the exploration of the data. We did some preliminary analysis of the data, get a feel of it. But to progress further and to dive into the data a little bit more, we are going to do some visualization. Visualization is a great way to develop a better understanding of your data, and Python has a lot of great tools for specifically that purpose. So let me just label this visualization. And we've already imported the seaborn, so we just have to perform the pair plot and using the iris data sets that we have. The hue is the species, and we're just going to set the size as 1.5 and close that off and run that. Now this is a tad small. Let me just change the configuration a little bit. So what I did is that I've changed the size to 3 and I get a much larger picture. So previously what we had was 1.5, and 1.5 is actually a little bit squashed, so we can also switch to 2 to get a slightly better visual of it. I think 3 is just about right. So what does this picture and actually tell us? And if you look carefully, what you can see here is that you have the sepal length and then you have the sepal length. You have the sepal length versus the petal length. So if you look at the different species of flowers, you have Setosa, versicolor, and also virginica. The Setosa has pretty short sepal length and also petal length. The green one is versicolor, has slightly longer sepal length and also petal width. And the virginica has even longer sepal length and also petal width. So this, you can see that there are actually some really clear distinction here. Along this part is actually the petal width with the petal width, so it's not so informative. But you can clearly see that there are some very distinctive relationship and also characteristics of each of them. So Setosa is actually quite distinctive on its own. It has pretty short petal length and also the sepal length is by itself. It actually is pretty short. Let me just do this visualization a little bit. So let's look at Setosa flower. So let's just look at the images. So this is what the 3 different types looks like. Although they look really similar, let's open up. Okay, let's go and look at the image itself. Okay, let's just blow this up a little bit. You can see that Setosa has this, and they all individually has very distinctive characteristics, and by visualization you can immediately tell that Setosa on its own it really stands out, very distinctively different. Whereby versicolor and virginica is actually very similar. There are some variations, but in terms of the sepal width, it's very similar in terms of length. If you look at the sepal width, again, they overlap a lot in the sepal width side. How about the sepal length? It's also pretty similar. The petal part is what distinguishes the two of them. In terms of the petal width and length, in fact, you can see that the versicolor has shorter width and also shorter length, and that's although there are a fair bit of overlaps as well. So that's the power of visualization, is to allow you to actually very quickly visualize and pick that out. Now the next thing that you really want to do is actually conduct a little bit of distribution plot. That's one of the way to actually quickly get some intuition. Is equal to, let's just use 1.2 This is plotting the historical, and we're gonna use the. Let's just plot this and see what it looks like. Let's show. Yeah, and I'm not too sure if we can set the size to equal to 3. Let's just bring up the documentation and see what is available for us to set. Yeah, so it doesn't actually have the size that we can control. Fixed size, yeah, maybe we can actually just use directly fixed size. Fixed size is equal to, let's say 12:8. Okay, we can directly control it via that way. And through this, you can also see some very distinctive difference between the actual flowers itself. This is basically the pure distribution of all 3 combined, and from this it's not really all that informative, because it just tells you overall what is the petal length distribution. You know, you have from 1 to 7, petal width is from 0 to 2.5. We can already see this from the earlier described output here. But what we really want to do, I mean, of course you will do these preliminary steps to actually get the distribution of it, just to actually see, you know, what is the normal distribution. The next thing that you really want to look at is the, okay, by species, each species of the so-called flowers, are they quite different? Let's do a subplot. And have a look at what it looks like. We just used one of the violin plot of seaborn, and we're just going to use the species, and we're just going to label Y as the so-called petal length, and we have the data is equal to iris. Let's repeat this. Okay, so we're looking at the second one, the third one, and the fourth one. Okay, so alright, I need to actually take these, proper label over. So I need the sepal length. Actually, it's not petal, it needs to have an underscore, and it's all small caps. So let me just bring that over. Let me bring that over as well, and finally let me bring that over, and that should gives me the full plot. 2 1 2 3 4 5. Let's run that and see. Okay, shift enter to run. Okay, cannot interpret the input sepal length. Okay, so I think there's just that space there, so let's just plot that out. Okay, so it's a bit small, so let's just change the figure size. So in order to change the fixed size, what we have to do is make use of matplotlib. Figure fixed size is equal to, let's just use 12:8, and we just run this and see if it actually cooperates with us. Okay, that's fine. Okay, so that's the right size. So looking at this, let me just, I really don't like the noise. Yeah, okay, so looking at this, what kind of conclusion can we draw? You're looking at the sepal length. You can see that the distribution is clearly shorter than both versicolor and virginica. Virginica has much longer in terms of distribution. The average length is longer than the versicolor. Looking at the so-called sepal length, what can we draw in terms of conclusion? The sepal width of Setosa is it has the widest distribution, and also the longest sepal width as well compared to the other two. Setosa has the shortest petal length and the shortest petal width, while the other two is very similar. Virginica has pretty much slightly longer, but fairly a lot of overlaps with versicolor. Now the other way that you can represent the data is to use the Boxplot. Boxplot is actually very similar to the Valin plot. So we're just going to use species. Wait a sec, it needs to be properly labeled as a text, and fixed size is equal to 12, 8, I believe is what we use. Okay, so notice that it's actually a very similar representation, although it actually did a flip. But the one difference is that with Boxplot, it actually used the same scale, whereas Valin plot used a slightly different scale for each categories. So with it does actually highlight slightly different different things when you use the same scale. You can see that definitely the Setosa has much shorter petal width and length, and clearly right. And also the other thing that you can see here is that the flowers all have longer length and much shorter width. Okay, just along the the visualization, I just want to highlight another possible plot that you can use under the so-called seaborn. It does have a scatter, does it? No, I think I might have to use pandas. Scatterplot, yep, scatter matrix, iris and fig size is equal to 12, 8, and we just plot it and see. Okay, so has no show. I'm sorry, grumpy. Okay, so looking at this, okay, it's deprecated, so you need to use plotting. Okay, right, plotting scatter matrix. Okay, that's better. It looks happier now. The only problem is that this looks a bit squashed. Let's use a okay, and well, this is not as clear, not so obvious when you look at this. I think I prefer using seaborn, which I can get a lot more, visualize a lot better using the pair plot rather than using the scatter matrix. Now, obviously, you can actually do a lot more. I think that's pretty much where I'm going to stop when it comes to the visualization video here. Now, what I would really like you to do, having demonstrate to you the different types of visualization that you can do, I'd like you to actually try your hand with this. Please go through the step-by-step, vary some of the parameters, like what happens if I change the line width, what happens if I change the figure size, can I change the edge color to some other color so that it's might be aesthetically looks better, or even study the so-called plot itself and see what you can do. And if you want to, you can actually download another data set and play with it. So at the very least, just take the next 10 minutes. I'm going to pause the video, of course. You please do pause the video, and for the next 10 minutes, run through at least what I've done, type in the codes and see what actually, and study the data, see what you can actually learn from it. So I'm going to pause right now to give you a chance to actually pause the video, and when you come back, I'll speak a little bit more. All right, welcome back. So did you manage that? Now I hope that went well. Okay, again, these codes are available for you to download and allow you to actually compare it. So in this video, what we've learned is how to visualize our data and interpret it. And the reason that I really want you to actually master this part is that visualization, presenting your data, is and the very important, the beginning part of your analysis to help you develop intuition, and also at the end of it when you actually present it to the stakeholder. So that's pretty much the end of this video and also this section. In the next section, we are going to start moving into the topic of regression. We're going to start to do our modeling using regression. So I look forward to seeing you in the next video. Thank you.